One of the main questions in plate tectonics is how fast do plates move? And again, we can determine that using one of our maps. We can measure the distance between anomalies. Anomalies are the same age on either side of the ridge, and we could calculate based on distance and age a velocity. The problem is, again, we have to worry about the fact that our map is distorted as you move away from the equator, and so we would have to correct for that mathematically. On the globe, we can actually make the distance measurements directly. There's no calculations involved, and so students can much more rapidly gather the data they need to explore the processes of plate velocity.
Right, so we can take the example of the mid-ocean ridge between Antarctica and Australia and go along this ridge and mark anomalies to see how far they are apart and calculate a velocity from that. So if we take anomaly 5N, 2N here, we can simply draw a line here and a line here, and okay, we've got now a distance, and we can measure that across and simply say, okay, that distance, we again know the anomaly age, and we can calculate a velocity.
So what is the distance?
What is the distance? Okay, here. So the distance is about 700 kilometers.
Okay, and the 5N, 2N is just about 10 million years. So we can easily do the calculation, 700 kilometers, 10 million years, 70 kilometers per million years, or 70 millimeters per year. So that's within seconds, the students have a velocity at a particular place.
And we can continue moving along the ridge to see how that velocity might change along the ridge. So let's go farther up the ridge over here. Again, we'll do 5N, 2N. And so up here, 5N, 2N, down here. Okay, so let's measure that distance again. And now we see it's still pretty close to 700.
So again, it's 700, so again, 70 millimeters per year. We can now keep moving, we can go further up.
Yeah. Okay, so we've got 5N, 2N again over here, and 5N, 2N over here. Okay, we can measure that distance. And so now we're getting a distance more like 600 kilometers.
So the velocity has changed. It went from 70 millimeters per year through here to something like 65. And if we went the other direction, we would see it change again. And so this brings home one of the key points about plate motions is that they may be spreading or rotating at a constant rate, but the linear velocity, the velocity on the ridge, varies with their distance from their pole of rotation. And so the quantities like the spreading rate and the spreading direction can be used to actually determine the pole of rotation that we use to describe plate motion. And what students can do, what we have them do in our class, is make these measurements at a whole variety of places, and they actually discover the pattern that it will reach a maximum, which we know mathematically should be a distance of 90 degrees away from the pole of rotation, and it will then decrease on either side of that to go to 0 as you get to the pole of rotation. So trivially easy to measure this here without the students having to get bogged down in a whole series of calculations.